Not a daily quiz, just a. Do you remember what we were doing on Tuesday? Okay. Wah, wah. As do I.
I don't know what to do with it now. Just gonna plug it in, slam it on the ground, and see what happens.
Mind you, therefore, it's good to be here at the council next week, Tuesday, September 28th, during the lunch. Stop by that table if you're interested at all.
Okay.
Yeah.
Yeah. Okay. We are going to pick back up in 1.6. I hope to finish 1.6 and move into 1.7 today because of tomorrow being an early release and having less time. Okay. So, since we don't have to do daily quiz or homework questions or anything like that today, start off with section 1.6, right after example 1 or 2 or whatever it was. This is the extra practice slide. Go ahead and do number 2. Show me that you remember what we're doing. And before I forget, last night I got through all of the quizzes. So everything is graded. I hope to put it in tonight. The handful of you that missed a quiz for whatever reason, we've talked. I just don't touch it. I don't put a missing. I don't do anything. So it doesn't count for or against you until that quiz is done. So don't worry about it. Just get her done before next Thursday so that I can put them in for midterm grades. Oh yeah, this is just regular class. Go ahead.
You can only not take out a factor of mistakes and subtract.
Correct. If it's a sum or a difference in the radical, you can't take anything out. It's only factors we take out of radicals. Okay, there we go. Okay, fairly straightforward. If I have f plus g, f minus g, f times g, f divided by g, I will take the f rule. Oh, that's right, we got to recalibrate. See, it turns out Frank's not a smart guy, but Frank was being sabotaged by his ex. Yeah. His ex is over there on the counter because, screw you, he went back to his high school sweetheart. I went back to the old laptop and went down yesterday, second hour, and had them re-image one of the old laptops into teacher mode. And it works just fine. And I heard it from the horse's mouth, from our tech guys. They cheaped out on the computers because they had to buy for the high school and middle school. That's what they've always done. I don't know why they decided to get them all new ones too this year, but that's why. They had to buy an extra 300-400 computers, so the official terminology was compromises were made. All right, so we got this, 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 and this. All right. Function operations are exactly what it sounds like. If I say f plus g, f minus g, f times g, f divided by g, take the f rule and with g rule, whatever the operation is. You just have to be able to clean it up because you know how to algebra. So just x cubed plus square root of x plus 1. X cubed minus square root of x plus 1. X cubed square root of x plus 1. Hi?
Can't you take the plus one out though? Or
It's a sum. If I had a number, okay, so you're saying like 1 is a perfect square, right? If I had 16x, because it's a product, I can take the factors out. But if I have 16 plus x, now it's a sum. Only when it's a product. Because a radical is asking about what to this power, in this case, what squared makes this object, this radicand. Well, if I'm saying what to a power makes this sum, technically it's, well, x plus 1 to the 1/2. If I take that and square it, I will get x plus 1. Okay? So no, I can't take anything out of there. And I saw on the quiz, I saw a couple of us try to do that. This one, I can't leave it like that. No radicals downstairs. Okay. The domains, though. That's where all of this was old hat. Can we do the domains? You look at the commandments of domain and you say, thou shalt not divide by 0, thou shalt not take even root of negatives, thou shalt not take log of non-positives, and to be continued. Do I have any of those three? Yeah. Thou shalt not take even root of a negative. So I find out what's going to make that radicand negative by finding the cutoff point. Because 0 is the cutoff point between negative and positive. So if I put in a -1, I'm good. -1 plus 1 is 0, square root of 0, perfectly legal. If I go even a hair lower than that, I go -1.0000005. Okay, now it doesn't work. So my domain is going to be from -1 to infinity for this and this and this. What changes about the last one? Now I have to go from -1 to infinity with a parenthesis to say -1 or -0.9999999999993. You're cool. But -1 isn't. Okay? No, it's really not. It violates the rules.
Who came up with these rules?
The proof that you can't divide by 0. Go far enough in math, you actually prove why math works. Like, you prove why domain can never include divide by 0. So, all right. So that was function operations, just basic add, subtract, multiply, divide. The new part that you got in Algebra 2 was compositions. Composition is when you put one rule into the other. So we all know that if I say the function of 3a and it's the square root of a squared plus 1, I plug 3a in everywhere there was an a. So now it's not a squared, it's 3a squared, right? And then you keep moving on down the road. You, however, going back to Mariah's question, what can I take out of here? Absolutely nothing, because it's a sum. Now, if I turned it into 9 times a squared plus 1/9, if I factored the 9 out, now it's a 9 times something. Now I can take 9 out because it's a factor. Here it's not a factor, it's a sum. Okay? So we know how to plug stuff into functions. Would you be cool if I said find the function of that? You just plug that whole thing in, right? So what if I had off to the side here, g of x is 2x minus 1, and now I said find the function of g of x. You're cool with just taking this and putting it in A? It's just written like this. That's a composition of functions. I put one function into the other. Y'all remember, like, I do Pac-Mans because I don't have the artistic skills for bulldogs. Y'all remember the original Toy Story? The little, like, nesting dolls? The bulldog opens its mouth, and then the little bulldog comes out, and it opens its mouth, and the little bulldog comes out, right? That's what a composition of functions is. Everything goes backwards up the chain. When I say f of g of x, I'm saying put g of x into f. Why am I talking over people? Okay. The difference is I write it like this. F of g of x. Remember Fogg and Goff? Okay. F of g of x says I'm going to take the g of x rule and put it into f. So everything goes backwards. So like this, in terms of functions, would be like f of g of h of j of x. I would take the j function and put it into h. Whatever that result is, I would put it into g. Whatever that result is, I would put it into f. It works its way backwards up the chain. Kind of like the diagram of the fish. You know, the whale eats the shark, eats the sea lion, eats the flounder, eats the plankton, like the food chain, right? The little ones go into the big ones. Well, if the whale or the shark eats a seal, but the seal recently ate a whole bunch of fish, bonus, right? It's still in there. That's how a chain of compositions of functions works. You didn't really see anything past just compose two functions last year. Now, the way it gets weird is when you start talking about what is domain and what is range. Because if I put something into this function, figure it out, and then put that into the other function, the output of this one just became the input of that one. Maybe like, y'all remember the function machine? Okay. You have the function itself, g of x. That's the rule, that's the machinery, that's the programming. It says do this with input. I throw in x. Right now this is domain. What comes out? So it comes out as y. It is now range or output. What's happening here is I'm going to toss something into the chicken nugget machine. It spits out chicken nuggets. But then you throw the leftovers into the hot dog machine because everything goes in there like boot leather. It doesn't matter. It's just literally hot dogs. They sweep off the slaughterhouse floor at the end of the day and chuck it in a grinder. Okay, it's whatever's left. No. Almost though. All the byproducts, you know, like you've heard of different grades of steaks, boneless wings versus bone in. Whenever they make that stuff, they're cutting off and shaving off parts. Where do those parts go? Some of it goes towards the processed foods like hot dogs. Y'all know that like the chicken patties or chicken breasts at Subway, they're not actually chicken breasts? No, it's not. It's a bunch of chicken parts left over from other processes, and it's glued together. It is literally like glued together in the shape of a chicken breast. Oh yeah. So here's okay. That was a conversational tangent here. What happens is I plug something into g of x. Whatever that result is, that was the range for g of x. But now it's going into f of x, and it's becoming the domain of f of x to then become range again. So the range of the input function is the domain of the final function. It means we've got to be careful when we're looking at domain and range of our functions as we compose them. Think about, okay, homecoming's coming up. How about instead prom? You cannot go to the after prom party if you didn't go to prom, right? That's why I went. I'll put up with all this crap if I can go like do jousting and play pull tabs. Okay, literally jousting, like we're on giant towers and you had the giant Q-tips and armored up, and it's great. Or we did sumo suits one year, jousting one year. We did the giant boxing gloves that are like as big as you. All inflatable stuff is great. Okay, but you can't go to the after party if you weren't allowed to the original party, right? You can't go to the after prom if you weren't at the prom. That's what we have to watch out with here. If I'm saying f of g of x like this, in fact, that's what this diagram is, f of g of x. I'm finding g of x and plugging it into f. Well, what happens if it wasn't allowed in g of x to begin with? Okay, it's not allowed in f of g of x. You're not allowed to the after party if you weren't allowed to the party in the first place. So, we just got to be careful with our domain. Come on down here and jingle, jingle, what? Oh. F of g of x says take f of g of x. Well, the f rule says take something squared and add 1. That something is going to be g of x. That's what this says. F of g of x is f of the g of x function. So everywhere that there was an x, I'm plugging in g of x. Cool? It's more getting used to the notation. You know how to plug something into a function, but you got to get used to the notation. Then you have to simplify it because you can't just leave it like this. You can't just leave it like this. You can't just leave it like this. Your next quiz, you can't just leave it like this. Oh my God, I see kids leave it like this all the time and they just move on. Just simplify it, okay? Don't get lazy, just simplify it. X squared minus 8x plus 16 plus 1 is x squared minus 8x plus 17. Okay? Now, domain. I know it doesn't ask for the domain. I'm going to ask for the domain because this is important. Look at the after party. Are there any of our 3 commandments of domain that may be broken here? No. So the after party says, yeah, everyone's allowed. But you have to go back to the input function, the original party, and say, were there any restrictions to that one? No. Okay, you're good. This would be like if we had an after homecoming. Everyone's allowed to homecoming. That's why all the freshmen come in there, and it gets weird. Okay? Like our first big high school dance, that's right. The ladies are going to be all over me, and I'm going to just hang out in the commons and hit my buddies and go, and think that attracts a mate. Like, God. So, okay, so I do it again, except now backwards. G of f of x. G, oh, wrong one. G of, so the G rule says take something and minus 4. That something is going to be the F rule. So the F rule is this entire thing. And simplifying it is, well, simple. Ta-da! So I look at the after party. Anyone not allowed? No. I look at the original input function. Was there anyone not allowed in here? Okay. So that means for both of these, they had a domain of all real numbers.
What if the domain is different for each one? What do you do in that?
We're getting there. In fact, I think that's the next example is do a composition with restricted domain. I know we do it. I just don't remember when. Okay, f of g of 2. You have two ways to do this. Method number 1 says if I know what the f of g rule is, this, well, then I'll just use that. F of g of 2 is 2 squared minus 8 by 2 plus 17. Now that I know what the rule is, I'll just plug 2 into the new rule. So I get 4 minus 16 is negative 12. Negative 12 plus 17 is 5. Okay? That's method number 1. Method number 2 is to take the chicken and chuck it in the machine and just watch it the whole way as it goes through the parts.
That's so bad. Is it alive?
No.
Oh, that's right.
Okay. Did you kill it first? It's like
No, I just like to hear it squawk in the machine.
my father-in-law, the first time that I heard him explain to someone else how they prep the cows for slaughter. You just get a 22. Poof, plop. Poof, plop. Okay. No, it's humane.
Yeah, what happens?
No, legit. Like,
It is because it's
done. You take care of the animal while it exists. When it's time, you end it quickly and humanely. That is our food source.
Usually they have like a little special thing. Just like shoots.
If you're talking about like actual slaughterhouses, yeah, it's like a piston. Yeah. But anyway, back over here. We're gonna accidentally make vegetarians. The other way to do this is to follow the machinery. Find what is g of 2. Well, find g of 2. Cool. Plug that into f. Plug that into f. Negative 2 squared is 4. 4 plus 1 is, oh, hey, look at that. 5.
So plug 2 in for G and then whatever you have.
So you find g of the 2, and that's 2 minus 4 is negative 2. Okay, now f of g of 2, I'm taking this and plugging it here because it was the answer.
So solve f of g and then put the 2 in for all the x's.
No,
These are the two methods, two different ways. Way number 1, find the rule, shove it in the rule. Way number 2, plug 2 in here, get the answer. Okay, plug that in here. Do it as a chain. Well, yeah, g of 2 is negative 2. So I will put negative 2 in here. You do it as a chain. Okay? Put it in the first machine, what do you get out? Cool, throw it in the second machine.
Which one do you like better?
Depends on the problem. Because sometimes when I, like here, this rule is a little more complicated than do one operation, do two operations. I would probably use the second method on this because the original functions are nice and easy. But what happens if I do all of the f of g stuff and it simplifies down to just x minus 3? Okay, 2 minus 3, negative 1. Ta-da! I would probably use that method because it was faster. That's why I say no both. Because, well, the right tool for the right job.
Isn't the first one only really useful if you've already done it?
Yes, and that's why we have to practice, can you actually find the function rule?
I think I'm going to watch this video just to get the ta-da again. I'm going to screen record it and then make a meme out of it for you.
I know that I've been memes before. Have fun. All right. So f of g, g of f of g of 3. Just to make sure that we're doing it right, start with 2a. We will do 2b, but start with 2a.
Why is so much stuff smaller? Why are we so quiet?
I don't know. Why are you so quiet?
That's why I asked you.
I mean, to be fair, Andrew wasn't talking, so.
I don't talk that much.
I know, I looked at my hand and I was like,
Yeah,
why do I
okay.
everywhere? And I looked at
Yeah. Okay. Where is that? In my
Wait. 4, 8, 12, 16, 19. Who's missing?
Because they're going to be a lot of us.
yeah, no, I was so you drive. So what do we do? Wait,
I don't know. We sent a message to that.
okay, I don't call.
Andrew, Liz here, Andrew, Father Mariah, Grace. 4, 8, 12.
I don't really want to be responsible.
Oh! Okay. Yeah. I counted the back 4 and then just kind of forgot Paul. Sorry, dude.
Never mind.
1, 2, 3. 27.
You just learned that? Wait, do that again?
Y'all know the finger trick, right?
Yeah.
9 times 3. You count 1, 2, 3. 27.
9 times 9. 81. My brain just froze.
Captain's log. At the ripe age of 16, student has discovered.
It's even worse because I'm 17.
All right. So, no, it's because remember factors of, or multiples of 9. Because you go down this way and then up that way.
Show me with different numbers.
You have a cool math tricks, I think. No, wait, can you do like 6 or something?
No,
Just 9.
it is a 9 trick.
No,
There.
I'm saying, can you do like multiple? I just want to see different things. Oh.
9 times 5. 1, 2, 3, 4, 5. 45.
No, you don't. Yeah, there.
So anyway, 2a, if I'm looking for f of g, f says take 3 times this thing plus 1. If I'm looking for g of f, I will plug in the entire rule.
Oh, that's great.
And you want to know what Dad's doing? You showed us last year as well.
Yeah, pretty sure.
You know, I'm pretty sure if I went back and you know, like, have you ever done those like minute multiplication quizzes where you have to solve 60 multiplication questions in a minute?
I loved those.
I did those in my 4th grade class. We called it rocket math, and you had to like go A through Z. I'm pretty sure if I went back and did that, I wouldn't be able to do it.
We had like a whole thing. You started at multiplication and went all the way up. So you had to beat a level to go on to the next one.
Yeah.
But they assigned us homework. So you had to get to a certain
We did it in one class and my
So how about this math?
Yeah, we like it. Let's keep going. Can we review geometry?
No. G of x goes into f of x. So I take the f of x rule, I plug g of x in there. Why am I still talking over multiple people? Shut your holes! Thank you. Make sure you distribute correctly. Combine like terms correctly. Okay. Make sure you distribute correctly. This entire binomial squared, 9x squared plus 6x plus 1. And you negate the entire thing. That's 5 minus 9x squared plus 6x plus 1. So you have a negative 9x squared, a negative 6x, a negative 1, and 5 is 4. What if that last one had been, I don't know, 12? Yeah, what if this had been 12? There's so many kids that will run across this and they'll see a common factor or they'll recognize a factorable quadratic and think they have to factor it because we just kind of pounded that into you in Algebra 1. No, that's the simplified form. If you have parentheses, it implies an operation. It implies something else must be done. You leave it in standard form, even if you can factor it. That just is the answer. Okay, this is a quadratic. This is a linear function. So the inputs doesn't matter, right? All real numbers for domain. All real numbers for the domain on both of these. So both of them have a domain of just all real numbers. If it asks for f of g of 3, I have a choice. I can either go to my f of g rule and plug a 3 in there, getting 9, negative 27 plus 16 is negative 11. Or, now that I know that this is a chain of things, I could put the 3 here, put 3 into g first, and say 5 minus 9 is negative 4. Now take the negative 4 and plug it in here. Is negative 11. It's the same thing both ways, but you have to choose which one you are more comfortable with. Okay? I want, where is it?
We need to find the domain.
All real numbers for both, I said, because they're quadratics and linear. So far, all of this is the domain was all real numbers. I think we're okay with that. But what happens when you do have a restricted domain? Okay. Example 3. Okay. When I do have a restricted domain, so you set up, if f is this rule and I want f of g is, well, the f rule says take 1 over a thing plus 1. So I rewrite whatever the end function is with parentheses and get ready for what's coming in. Well, what's coming in is the entire g rule. G of x being plugged into f is x squared minus 9. Make sure you simplify it. 1 over x squared minus 8. Now, I need to look at the after party. Who's not allowed to the after party?
0.
Lies. 0 minus 8 is negative 8. I can divide by negative 8.
No, I said you can't divide by
Oh, I can't divide by 0. So how would I find what isn't allowed? Okay, set it equal to 0. Say if x squared minus 8 equals 0, then x squared is 8, then x is plus or minus 2 root of 2. Always simplify your radicals. So those are the two that are not allowed to the after party. We just know if we let Taylor in to the after party, there's just going to be problems. Okay, so we're just going to say no, you just don't bother. Okay, those two are not allowed. Sorry, Taylor. Okay, I have to go all the way back to the beginning though. Go back to your input function and ask the question, was there also a restriction of who wasn't allowed to the original party? No. Okay, that's just a quadratic. So that one's fine. So this is indeed the only thing that's not allowed. I would say, here is my final answer. The domain is negative infinity to negative 2 root of 2. Can't touch this. Negative 2 root of 2 to 2 root of 2. Can't touch this. And 2 root of 2 to infinity. Think about the number line. I'm looking at this negative 2 root of 2 and this 2 root of 2 are the only things that aren't allowed. So I need to say all of this, all of this, all of this. That's why we put a union on this, excluding just Taylor. We put a union on this, excluding just Rudy. Okay? This is also something that I saw in the quizzes when we had the problem on writing domain. I saw a lot of kids just forget the middle here entirely and say negative infinity to negative 2 root of 2 union 2 root of 2 to infinity. Well, that just says here and here. You completely forgot the middle of it. You have to include the entire thing. You are only excluding these two values. Okay? Go again. If I have f of x, f of a thing says take a thing and square it minus 2. That thing is going to be g of x. So I plug in an entire x minus 3. What's a radical squared? Or sorry, a square root squared. Just the radicand, just whatever's inside that radical. So I end up with, get back here, Green. We get x minus 3 minus 2. Okay. Now, if I were to look at this and only look at the roster of the after party, x minus 5. Well, it's a line. There's no restrictions to the after party, but look at the input function. Who wasn't allowed to the party before the after party? Okay. So this one has a domain of all real numbers. This one has a domain of 3 to infinity. You have to put these two together and go with the most restrictive one. Okay? Even though everyone is theoretically allowed to the after party, if you weren't in the building in the first place, you can't go. Right? This was the input function. So that means my final answer for domain has to include that. 3 to infinity. That's the catch to compositions. We know how to plug one thing into another thing, but you have to look at the domain of both. If you need to write this, when looking for domain of compositions, the two places you need to check are the final answer and the input function. Okay, you have to check both. So, can you put this weeble into that wobble and check their domains? Yes, ma'am.
What if they were both restrictive, but in like
You have to meet both conditions. Think of it as an and.
combine them together?
Think of it as it has to meet condition A, intersect condition B. It has to meet both. Okay? Mom says you're not allowed to date freshmen. Dad says you're not allowed to date until you're 17. Okay, you must make both of them happy. I can't date until I'm 17, and I'm still not allowed to date freshmen. A, y'all terrify me. No.
Why for your kids?
Don't date freshmen, bro.
Do you want us to do both?
Yes, both, please. No, you just got older. Freshmen are always like this.
So we were like that. Oh, remember Brady's video?
I still have Brady's video. I have a video of one of our seniors when he was a freshman getting all heated about me mocking freshmen. He said, "What's the big deal? Why are you always bagging on freshmen? Why you got to do that? Freshmen aren't so bad." I pulled out my phone. I said, "Could you say that again, please?" He's a senior now. Guess who's going to have that as part of the senior slideshow? Brady Croteau.
He hates
All right, come on, do the thing, do the thing. Both of them. F of G for both.
Wait a minute.
F of G. Not F times G, F of G.
So we put F into
G into F. You always work it backwards. Read it like manga. Manga, Japanese cartoon books. You read them backwards because all of their stuff is right to left.
Isn't Chinese like, so it's just X squared equals squared?
I think Mandarin is. I don't know if like there's different types of like there's Cantonese, Mandarin, and I don't know.
Yeah, it's so great.
Yeah. Yes.
They're gross.
I had someone say they were tasty.
A unicorn? There's a unicorn?
Well, doesn't that extend your life? Like,
Are you making a Harry Potter?
Wouldn't this be all real numbers?
I hope not, because the author shall not be named.
Wouldn't this be all real numbers? Because like anything squared, like even if it's a negative, minus the same thing, it'd still be like a positive.
I don't like
Well, not all real numbers. Lars, there is one that is not allowed. Set the denominator equal to 0 and solve. It's everything but 0. Set the denominator equal to 0. Whatever the answers are, get rid of those.
So this is all around numbers, that's where number 2. Do I look at that one?
I don't know.
You missed the other one.
I'm good.
So like, since that's all real numbers, and that's one is all real numbers, do I have to look at that one too? Like, for the domain?
In this case, it's always the input function, g of x. Correct. So anyway, sounds like we're done. F of a thing says the square root of that thing plus 1. If that thing is g of x, which is x squared minus 1, you get this interesting phenomenon where that cancels, I just get x. Does anyone remember from Algebra 2, if I compose functions and end up right back where I started, what are they? They have a special relationship.
Is there a special name for it or something?
Yeah, I can do this thing, I then do that thing, and I'm right back where I started. This is, don't do that. That is literally the identity, yes. But what about these? All right, everyone. Eyes forward. Stare directly ahead. I don't care where you're sitting. Stare directly ahead. Everyone turn your head 90 degrees to the right. 90 degrees to the left. How many of you are now looking the wrong direction instead of at me?
Well, I'm sitting somewhere else.
Okay, yeah. 90 right, 90 left. Wow. I did that to the freshmen the other day, and y'all were about the same ratio. Okay? So, what is that called? What is that called if I add 90, subtract 90? Back to where I started. The opposite of times 5 is divide by 5. Starts with an I. Inverse. Inverse operations create the identity. Times 5 plus, or times 5 divided by 5. Add 5, subtract 5. The additive inverse will result in the identity. Okay? These two are inverses. In fact, that's what 1.7 is about. You actually prove, just like back in Algebra 2, you prove that things are inverses by composing them. If I say f of g and g of f, and they both come out as the identity, that means if I throw it in this machine and then it goes into that machine and then it comes out the exact same, those machines must cancel each other out. Okay? They are inverses. Try over here. I have f of g of x is 5 over a thing, in this case, x squared plus x. Well, if I set x squared plus x equal to 0, there are two things that are not allowed, right? 0 and negative 1. So I look at the after party, says x cannot equal 0 and negative 1. Look at the input function. Are there any restrictions to the input function? No. Those are the two places you look. So my domain is going to be negative infinity to negative 1, can't touch this. Negative 1 to 0, can't touch this. And 0 to infinity. Please make sure that when you write this, you write it as a number line. Don't put the 0 first. Don't say negative infinity to 0, 0 to negative 1, negative 1 to infinity, because then your number lines are like overlapping and incorrect. Say it as one big number line, just excluding those two. Okay? If you got room somewhere on here, I would also like you to do G of F. Find a margin, go above that, box it in. Just that one. I just said that we ended up with the identity, so those are supposed to be inverses. I would like you to do G of F, and if these really are inverses, we should end up with X again. But check its domain. Okay. If I plug f of x into g of x, squaring a square root cancels out, inverse operations, and then the plus 1 minus 1 are additive inverses, they cancel out, I end up back here. But this may have a domain of all real numbers, but I have to check the input function. Who wasn't allowed there? Specifically from negative 1 to infinity is my domain. So the most restrictive between negative 1 to infinity and real numbers is negative 1 to infinity. That's why y'all remember that a radical might look like this, whereas a parabola would look like this. If something is truly an inverse, it mirrors across that line. Well, those don't mirror because this is missing stuff, right? That's why to make a radical and a polynomial actually be inverses, you might have to restrict part of that domain. Otherwise, they won't truly be inverses. Talk about that more in 1.7. Okay. Decompose a function. If I can put functions together, can I break one apart? Don't overthink them. In fact, the solutions for these, they might have a solution on there, but it's going to say next to it, example answer, or student answers may vary. When you do your homework, don't just copy the solution manual to make it sound like you did your homework. There are several in here who are doing that. You think I don't know? I do. Don't cheat, stupid. Okay? If you're going to cheat, don't cheat, stupid. Don't write sample answer and then what the book said. Don't say student answers may vary on your homework. Yes. I have someone do it every year. Also, your vocabulary, when you just copy what is in the solution manuals, if it's not the vocabulary that we used in class, it's pretty obvious that you're just copying it. Okay? Be smart. Okay? Don't cheat, stupid. All right. To decompose a function, remember that f of g of x, I plug g of x into f of x. So to decompose them, I want f of x to be probably the most difficult or the ugliest part of it. So you save that for the end. Like a little kid eating your dinner. You were always dumb and you left the broccoli for the end. You're like, score, mac and cheese. Dessert? Nah, bud. You eat your vegetables. Now. He's 4, so we're hitting that pretty hard right now. What is the ugliest part of this? What is the most annoying part of it? What is going to be the most difficult to work with or to incorporate? The radical. There's the radical part and then there's the cube part, right? Do I want to try cubing something at the end? But then I would have to figure out what radical goes in there. Or what if I just said at the end of this, I'm going to square root of x? What would g have to be to put in there to make this? Isn't that nice and easy? Because now if I take f of the g, well, I'm just plugging this right there. Take the ugliest part of it and have that be the f of x. Have that be the last step. Okay. Now, I could do other ones. There are other ones. In fact, there's multiple for all of these. Read the rest of this. Neither function may be the identity. No, you cannot just say f of x is x cubed minus 4 and g of x is x. No. You can't do that. Okay. Part B. Okay, now we're dealing with quadratics. I think you know enough about quadratics that we can make this one a little bit better. What do you notice about it? Just some pattern you realize. If I can take out a 2, could I just say f of x is 2x? Then, what would I double to make this? Okay. No, parentheses, remember? You're plugging this in for x. Okay. What do you notice about this? It's x plus 5, the quantity squared. So I could also say f of x is 2x squared. G of x is x plus 5. Because now, if I plug this in here and square it, I'll get this stuff and then double it. That's another way I can do this. Here's a really nice one for polynomials. F of x is x plus 50. What do I plug in there? Right? Each time I'm taking this and plugging it here. I'm taking this and plugging it here. Taking this and plugging it here. In every one of these cases, if I put G into F, I end up with H of X. They're all correct. So you choose whatever pops out to you. As long as you're not using the identity, you get to use anything. I won't do it now. You could have this with a masterful complex equation that ended up squaring and then cube rooting, and then at the end you would actually take it to the 6th root, and then the whole honkin' thing, a square root over that. You just have this big mess and plug in like x plus 1. Yeah, but that's difficult. I don't want to do difficult. I want to do easy. So don't overthink it, but also don't put the bumpers up on the lane. You can't use just equals x. Okay? As long as you can find 2 and you can show the composition of f and g actually is this, go for it. Let's see what you got. Get creative. If you think it's this, can you do the composition and prove that it actually is this? Check with your neighbors. Maybe they point out to you, nah, math don't work that way. Maybe you point out to your neighbor, nah, math don't work that way. Okay?
This is what I have. How many answers should we have?
Just the one. You don't need more than one. I'm just...
Oh yeah.
That's why I said
That's so good.
take your ACT after pre-calc.
Mine's ready.
Because kids will go on and do trig and calc and forget all of this.
My brain broke.
Hi?
Forget all of it.
Can you go negative x?
Will...
Is negative x called identity too?
Oh, I got it.
Why?
Loophole! Okay, someone found a loophole. There are loopholes where you can not use the identity. All right. No. Go show everyone. That was great. Go. That was beautiful. As everyone in the room collectively face palms. Does it work?
Yeah. You get mad at me?
You got me.
In history, when they asked what happened before the Titanic sank, say something.
The dinosaurs died. Okay.
They built the ship.
Now, yes, that does work. Did anyone see this one? Anyone see that one? Okay. Could I do f of x is x plus 1?
That's the one I did.
Or minus? They work, right? Could I get Taylor on it and say everything is x plus 50? Every single time. And then just whatever this is, subtract 50 from it?
Huh?
Yeah.
Right?
Why did I make it so complex? Why did I have to do the x squared equals like x minus?
If you see it, use it. If it's not the identity, you win. Okay?
And that's when you get a scholarship.
All right. What is the ugliest part of this one? It's a fraction. It's something over something. So make that your last part. There you go. Could I also say exactly what Taylor just did? I mean, yeah. So now, do I want you to rely on this for every single one? No. Yeah. Okay. Fine. F of G. All right. I want a little more practice with this one because I saw hesitation on it. I would like you to find f of g, g of f, and
G of 2.
because I would rather you practiced it now in class than stared at it on the homework and said, dude, what? I would rather that you practiced it now. Just 8, yeah. Find f of g, g of f, and f of g of square root of 3. Sounds like we're saying f of g. I mean, I have known kids who have lit their books on fire, so.
Dude, that's me. No.
Like during class.
No.
Like during the.
Yes,
like
just bring the lighter into school.
Like after school, I know they burn all their stuff
Like
because
during
they're
the
sick
course?
of school, and then they don't realize they're supposed to return their books, and now they have to pay like a lot of money.
I was not.
We got new books at a school I was at before this one. The old ones were in such terrible condition that no publisher would buy them back. So we just let kids take them if they wanted. And one of the Hicks backed his truck up to the emergency exit on the side, and they just loaded the back of his truck with Algebra 2 books. And they had a bonfire.
Are you kidding me?
Time.
You're not gonna get any help
It's
with
like
it,
when you know when you try to find like.
No.
Come on, finish it off. F of G, G of F. Find them both.
And the principal was like, okay.
Yeah. No, we're just giving them out to any kids who wanted them. There were kids who were blasting holes in them, using them for target practice. Other ones were burning them. Yeah.
My house got struck by lightning this summer, and it surged my Xbox. So we're gonna go take it up to a friend's property and fill the vents with tannerite.
Make sure you're at a decent enough distance. That's effectively a Claymore mine.
Look at that. Beautiful. That's what I thought. I definitely kissed her.
There's no eyes, because eyes are imaginary.
I realized that I did. I don't want to talk about it.
I'm not sure how much of this is side conversation to distract from attempting, or I'm already done and get it.
Yeah, I fixed it. I just realized what I did.
I don't like that.
I put a negative where I did not need a negative.
Oh, it was a problem. You didn't have control over it.
I looked at that and said, no one said I was smart. I know, I don't even know how I got into this one.
You can't.
Oh, they're good.
Oh, yeah, because yeah.
I might be good at science, doesn't mean I'm good at math. I don't know how I got all the next. I asked
Those
them
are
about
just gonna be.
I know, I struggled with algebra 1 so much. Because I was like, I get 7 and 8. And then geometry and algebra.
Just pull it out.
Geometry. I got 100% in my final in geometry. And then second semester we didn't have
So
a
you
final.
put 1 over square.
Okay. Do we at least have things in the correct spots? Set up. Everywhere that there was an x, I will put the g of x rule. Everywhere there was an x, I will put the f of x rule. Here, it's just 1 over x squared minus 3. Over here, I have 1 over, remember, square this, x squared minus 16x plus 64 plus 5. Or, if you get common denominators, that's 5x squared minus 80x 321 over x squared minus 16x plus 64. Okay. Common denominators. You have to multiply this by the the quadratic over the quadratic. No. I said I would take this or this. They're both the same. Okay. However, this was chapter 9, algebra 1. Okay. So, if I look at this one, I say my restrictions. Right now I know x cannot equal plus or minus square root of 3. Look at the input function. Were there any restrictions to g of x? No. So that just is my domain. Negative infinity to negative square root of 3, can't touch a span, in and out. Negative square root of 3 to square root of 3, can't touch a span, in and out. And square root of 3 to infinity. Fast play. And the other one, my denominator is x minus 8 squared. So the things that aren't allowed here is plus or minus square root of 8. Or no, just, no, back that up. Just 8. X cannot equal 8. There we go. I square rooted when I shouldn't have square rooted. Okay, but look at the original. Oh, hey, we're still okay because they shared the same thing. They both said X can't be 8. So this one is negative infinity to 8, can't touch a span, and 8 to infinity. All right? F of g of square root of 3. You can't. Does not exist. Because that was one of the two guys not allowed in. Okay. Y'all, can you actually do the decompositions without resorting to tailoring it? Okay. All right. Composition of real-world functions. I actually want you to cross out the example part of this. I really need to change my notes. They overcomplicated the living hell out of this. It's just a linear equation. Instead, how about legit real-world example of composition of functions? Who here has ever worked food service? Okay. So a good chunk of you. You get someone who comes along and they've got that coupon that says $5 off their next meal. But then they also have I showed my student ID, I get 10% off, right? Which one you do matters. It depends, different places. Like maybe there's a lot of places who will do military discount. They'll do student discounts. I know my buddy at the game store, he'll run promotions every now and then where if you show your student ID here or BH, he gives you so much % off. Like, it's a thing. You are supposed to do it a certain way depending on whether you are the consumer or the employee. Show you why. Computer Store offers 15% discount to college students. They also got a $100 off coupon. So I'm going to write both of those as functions. Well, think about it. I mean, if you got a decent laptop, you're probably looking $600 to $2,100. Like,
So like the opposite of our school computers.
all right. Find the functions to model the data, and down here they even tell you C and D for the coupon and the discount. So if I say a 15% discount, that means the discount in terms of the price is going to be, well, if I have 15% off, 0.85 because you will pay 85% of the price. Right? 15% off, so you pay 85. The coupon says $100 off. X minus 100. The price minus 100. I would like for you to find the composition C of D and D of C. Find them both, simplify them both, and then we talk about the answers, like what they mean. I need to.
Discount first. And then take $100 off. For the customer. That's what you want.
Okay, there is D of C and C of D plugged in the right spots. In both cases, if I were to distribute, this is 0.85x minus 85. This is just 0.85x minus 100. So no matter what, it's going to be 85% of the price, but then what you take off changes. Which one's cheaper?
C of D.
C of D. Because when you take a percentage of a thing, what? I'm so confused. Okay. This, like literally a fairy came and presented a present. Presented a wow. Shh. Be still. There you go. This one I'm taking $100 off of that reduced price. This one I'm taking $85 off of that price. When you take a percentage of a thing, if I'm talking about I get a discount, don't I want that discount applied to a larger number? Because I would want to take 15% of 1,000 off instead of 15% of 900 off. Right? So where this first came into play, I had a kid in here when we did this in Algebra 2. I talked about this and she had the, oh, those assholes. Like she was so mad. She worked at Applebee's. And they specifically trained their employees to always apply the coupon first, then the discount when they rang it up. And you'd say, well, it's a difference of like $85 on this gigantic laptop. On your like 2 for $22 entree, that's not a big deal. That's going to be the difference of like 45 cents. But what happens when you're doing that to 2 million customers a day? Okay. Now, when I used to shop at Menards, we used to do a big summer project every summer. Wow, I'm so tired. We do this big project every summer, and you know they got the rebates. Like they trick people into thinking it's cheaper because it's always 11% off. I would take the rebate amount, the this much off of your next purchase over 3,000. I would apply that first. Then I would have them ring up the discount. Or the other way around. No, God damn it, I'm tired. Okay. I would always force them to do it a certain way because when you're talking about something that's a $4,500 project, I literally saved hundreds of dollars doing this. When I go to, say, Applebee's, and I've got the gift card that says, or the card that says $5 off your next thing, and I'm going to get a discount, I will always have them ring up the discount first. They come back to my table and I say, oh, I'm sorry, I also have this. Forcing them to then do that. And then I give the difference to the waitress. Screw the company. I give it to the waitress. Okay? But it does matter. Okay, slow clap. Okay. But no, this can legit save you money. Compositions can save you money if you know what's going on.
Do you notice my messages to you? These good.
Yeah.
Every time there's like a really every time there's a face, they're different. See, this one's got this going on today. And then we got this